Okay, so today we're going to discuss particles. Um, Now, in particular, it's very popular in cinema to use X particles, but I'm going to talk about another way of having a lot of flexibility, doing whatever, essentially what you want with particles from Houdini. Houdini is, that's one of the things they're known for, is to be able to do all kinds of effects. Uh, so let's get started. Let's start looking at this at a simple example in Houdini. So let me go back here. Let me show you this. If we go back up to the object, we have a sphere object. And what we have done is underneath there, we've added a bunch of stuff. So this, and I kind of sort of borrowed this example from something Maxon did a few months ago. But I will come back to the attribute VOP, but let's look at the PopNet first. This is the heart and soul of doing particles. So you need a pop object. The pop object lets you control certain aspects of the particle system. And then you have a source. Now the source, this is where you can control all the things that you think about with particles, like birth rate, max points, life expectancy, all you've seen in particle systems. But it needs something, a source. And in this case, we're using the first context geometry. Now, what that means in terms of Houdini is, let's go back up here, the first thing that is plugged in. In this case, it's the sphere, which has gone through this attribute VOP, which I'll talk about in a minute. And it goes in, it takes, this really doesn't do anything right now. You can have other sources and so on, but this is a merge. And this, it's going to take this source along with this pop object, which controls various things as we've seen. Initial geometry is can give you an initial state of the the pop object. We're not going to address that here. And they go into a pop solver. A pop solver is what actually creates the particle system, and you have different things you can set here, various things. If you look in here, you see it's fairly complex, that you've got our inputs and so on. And this is what takes these and generates your pop variables. Your pop output. So in this case, we have, let me see, inherent velocity. This is important. This determines what the particle is going to do. We're inheriting any attributes, but also velocity. And you can either use it, you can add to it, or you can set an initial one. So right now we're just using it and it's 0. So when we go up here and we run this, it just doesn't do anything. So then we got this in this case. Now also we're not using gravity. If we were, then that would be another thing altogether. That would make everything go down. Now you can do there is a node called an anti-gravity that would allow it to, which would counteract the gravity and allow things to fly all over the place. This is a color node, and the making it random, and you can see now you get the different colors, and that goes out to, in this case we're talking about bringing something over to Cinema, and things you can output it in what they call a redshift proxy output, which is essentially a bunch of redshift with .rs files, which essentially, I guess you call them redshift frames, that the redshift has an object in Cinema that knows about these. And of course you have your Alembic, and the Alembic will save this this will save an Alembic, and you want to try to save, by default it's pretty much going to save everything, which can be very important, which we'll see. Now getting back to this attribute bop, you can do all kinds of things here. You can put a noise, and you can change different things. Basically what it's saying is this value here is going to drive one of these values. Remember, and this is important, when you, let me split the pane, and what I'm going to do here is a geometry spreadsheet. You notice you have all different values here. At this point you don't have any color, but if we go back up here, and you can see the color objects, the color changes of the different items is different depending on where you are, what frame you are. Like if you're back here at frame 1, there aren't so many objects, right? And they're all, since we were doing it based on aging, I believe, they're all relatively new. When you get over here, let's say here, you have objects of different ages, and they're going to be different colors. So here's all your data, the location, the color, whether it's alive or dead, because remember, you have a life of points, and so on. If you go to this color one, so here you will see the different colors. And so getting back to our attribute VOP, in this case, the velocity is driving the color. You can have the age drive the color. You can have different things drive this position, the velocity, the force, the color, etc. Let me see something here. You have different noises. So you can have, let's see, one eye noise. Let's see what that is. So you can put this here, and we can have, let's see, velocity. Let's put that into jitter, and then let's put see if what that does, because we have different let's see, that does anything. And you can see so this is the type of thing you can do here. You can put in noises, you can have different things drive different things, and that is what a VOP does. So that's your basic setup of a simple simple particle system. Now, one other thing is in our PopNet, or is it? Yeah. Let's see. It would be here in, believe. So you can inherit velocity. We can use add to inherent velocity, and we can say this. So now let's go back up, and now what's going to happen here is, see, notice they're flying all over the place now because we've given it some velocity, which we did not have before. And that's the kind of thing, let's see if we can see this. Here you go. Before it was like 0, and now you can see it's, so that's the kind of thing you can do here. And obviously you would do other things if you may want to control your velocity, make it go, control where these particles are going. If you have gravity, they're all going to go down. You can have where if it goes out, I believe here you can set something up so if it goes beyond a certain point, they're just going to disappear, they're going to die. So if you don't want them going beyond a certain point, there's a lot you can do here. Now another example, let's see, I am going to save this and I'm going to open a different example. This is a fireworks example. And now this is a little different. This one comes out of this shelf here. And so what it does is it sets the particles and our little pop network differently. Now notice here it uses the anti-gravity, which is what allows the particles to go up. And as opposed to, you see this, we just didn't have anything. We had no gravity, we had no anti-gravity. And how much force in what direction. So right here is where it'll tell it to go up. So the big stuff is it lets you see examples initially, and then you can modify them to what you're actually trying to do. It's a very good teaching device in a way. So when we go back up here, you're like, okay, so if you try to save here, put let's say a alembic, can't do it here. You can't do it up here. No. But what you can do is here, notice I had the same thing. And you can also cache, they also have a cache in here. So you can have your redshift output or your alembic output. So let's talk about these. No, I didn't want to do that. But let's talk about these. So the rope alembic saves it to an ABC file. You can specify where it is. I think it's, as I said earlier, you want to take everything and put it in here so that you get the full things from that example that potentially Cinema can use. Now, proxy output, again, this, instead of saving one file, it saves a set of files, one for each frame. And it will save pretty much exactly how you get what it's going to look like in Redshift. Now let's look at that for a couple of things here. We have an out, which is just our Redshift settings. This is similar to the render settings in Cinema, and it's kind of not real intuitive. Oh wait, this was the that's interesting. So you can tell it where you want to save it. I thought I saved this one out. No, I didn't. Not as a rope. You can give it a name. And of course they have these, like this is frame number. HIP is the location of where it thinks your project is. And that can be changed in variables. So my HIP is particle test. Probably want to set a subdirectory for that, and so on. Okay, if you were rendering out, this is to render it out. The other thing you have to look at is your materials, because you want to bring, what you're trying to do, if you are going to render out to RS files, what you want to do is you want to get it looking the way you want in Redshift here, and then it is going to save it out that way in a way that Cinema can bring it in and understand what's going on. It will get the materials and so on. So in this case, I set something up pretty simple. I have a user data color, which is going to get the color attribute of the particle. A ramp, which is going to map that to a color ramp, and I think this is here where you can choose different types, some presets, and then it's going to put it out to this very simple material. Okay, and so then when you go back and you go to the Redshift rope, now I found for some reason IPR didn't like, but if I did render view, you can see it rendered out. Now the color's a little different because I was using that material, and this is what you're going to get for that frame. So those are the basics of what you're going to be doing in Redshift. Now you want to bring it into Cinema, so let's I believe this is the fireworks. So notice if it's going to give you pretty much what we saw in the in Houdini, which makes it nice so you can see it. The problem is because it's particles, you can't really see it in here, but you can see it here. And what you do, and let me show you the other one, again, similar thing. So what you would do is, again, redshift render view, and you can see our particles. And this is going to look at what it looked like in Redshift and Houdini when we exported out to .rs files. So how do you do this? So let's do a new, let's see, let me show, this is going to be in a, let's do a new project. And what you need is a Shift C Redshift RS proxy. And you bring this in, and then on here you just go to your path. So in this case, I think it is particle 2, and click on the first one. It knows that this is a sequence. So what you need to do is, we can do the mesh, and we're going to go, this is important, go to animation. Now ideally you would set this to the number of frames. I want to do that. 240. Let's see. There we go. And what we're going to do here in animation is we want to turn it to simple. Detect frames. It's going to detect those frames, the frame rate. And when we run this, oh, that's one thing. We probably want to get in really close here. You probably generally want to export things in Houdini at times 100, because it's going to come in real tiny. Let me see something. If there's a, let me just go back here for a second and go back to our fireworks particles. Okay. Output. Okay. I don't see how you do that here. You may be able to do it. Yeah. Preview. Let's see something. Let's try this as 1,000. See what happens. No, it only goes up. So this is not size. I don't see how you can get. There may be a way of doing size. I don't see it. So you bring it in. Actually, you can also do something here. Probably you can do something here, or there. The scale, you can scale it up. We're just going to come in and you can see the box getting bigger and bigger. Now you really can't see it, but when you go in to, we need to change the renderer. edit render settings, because this is going to be redshift. And the other thing that can drive you, at least look on in my redshift, is this is it keeps looking for. See, so to clear it up, I just and 709, and then we go to redshift render view, and you can see it shows our item. So I think that's the easiest way to do it. The other thing you can do, let's close this, is I did import it as an alembic. And one thing I noticed when I look at this is when I did it as here, when I did the import, let me get rid of this and do it again. See if I can get this to work. Okay, so we're going to do merge project, and we're going to do noise to ABC. And here you can change the scale. First this would make it a thinking particle, and then I couldn't really capture the differences in the colors. Here is a polygon object. If I brought it in, notice it has this color, which I think could use. You see, which I think we can use when we're making a material to give us the differences in color. Let me show you this page real quick. This is from Maxon's documentation. It goes through importing alembics, and this is where I saw this. Now maybe you could do it for thinking particles. I just have to do more research into that. So let's see if I've covered everything. So by doing this, you can easily go, especially using the .rs files, you can easily create a particle, make some kind of particle creation in Houdini. You can render it, you can see what it looks like, you can get it just how you want it, and then by doing the .rs, you can bring it into Cinema looking exactly how you envisioned it in Houdini. And but you can also again use the alembics, and the nice thing about them is they don't require you use redshift. There are a number of softwares you can bring alembics into. In addition to Cinema, you can bring them into, of course, Unreal Engine. I think probably most softwares today will take alembic objects. So that's why you might want to use alembics. So I think we covered quite a bit of material here, and hopefully this all made sense to you. Please, if you have questions, certainly put them in the comments. And I check the comments, so hopefully I will be able to find you an answer. I'm still learning this stuff myself. And if you like this content, then subscribe. You'll see when I put more things out. Give a like. That YouTube seems to like that. So anyway, thank you, and I will speak to you next time. Take care.